Ladies and gentlemen of Algebra 2, welcome to Unit 2. This is talking about relations, functions, and linear equations and kind of what the difference is between all of those and kind of what the relationship is. Let's kind of look at it. If we're looking at a table that shows maximum lifetimes for some animals, and we're looking at ordered pairs, so this is kind of what we're doing. So we're looking at this information and trying to think about it as ordered pairs. So if I want to think about it as ordered pairs, here's what I'm going to do. It's going to be, so it would be like 12, 28. It would be 15, 30, 8, 20, 12, 20, and 20, 50. Now this would be a relationship at least, okay? So it would be a relation between the average number of years that they live and the maximum number of years that they live. So that's kind of the relationship we're talking about. So if I look, here's kind of what it should look like, my ordered pairs. So my domain is going to be all my inputs or all my x values. Domain is another way of saying input, and range is kind of like an output. So my domain here was going to be 12, 15, 8, and 20 should be there as well. My range then would be 28, 30, 20, and 50. All right, so this is going to be kind of my x coordinates. This is going to be the y coordinates. And a function, if something is a function, it's got a very, very specific situation. So each domain element, each thing in the domain, pairs with one range element. And here's what that means. So when I look here, so when I look at this thing, if I've got one input going to two outputs, that's bad. All right, so if I've got one input going to one output, that's fine. So vertical line test, if I'm graphing this relation, if I can draw a vertical line and only hit the graph once, that's good. So this would be a function. Here, I hit twice, that's not a function. Okay, so no function, that hits twice. So I'm looking at x, domain values, is going to be x coordinates. Y coordinates, the output, is going to be my range. So here, if it's going to be a function, I can only have one thing to one thing. All right? So that means if I've got 20 going to 15, but then later on I've got 20 going to 12, that means it's not a function. So if you take a look at your graphing calculator, if I go and go and put that in and graph it, 3x squared minus 5. So take a second, graph it. So this one is going to look something like this. All right, that one's going to be a function, yes. Okay, because I can draw a vertical line, I'll only hit the graph once. All right, this one, if I throw this in here, so let me take a look at this. So if I go square root of 1 minus x squared, and then if I go negative, that same thing. Oops. Apologies, I was trickier than I should have been. So if I graph this, I end up with this and this. I end up with a circle. Problem with that is when I go to draw a vertical line, I can hit this, and I hit two places, That's my dead giveaway that it is not a function. Okay? So if I take a look, domain and range here, what am I dealing with? Well, domain, -4, -3. Ooh, let's change colors here. -4, -3, 0, 1. My range here is going to be 0, 1, -2, 2. So now if I look, each thing only goes to 1. Okay, I don't have -4 going to 0 here, and then somewhere over here having -4 go to something. So yeah, this is going to be a function. Here, domain is going to be -4, 2, 3, 0, -1. Range, 3, -2, -4, -3. So here, yeah, this is going to be a function, because if I draw a vertical line anywhere, I only hit all the points once. So yes, it's a function. So, function notation. If it is a function, f of x comes into play. And that basically just means, yes, this is a function. X is the variable that we're, doing something to. And so this is kind of what we're calling the function. So, you have independent, dependent. Independent is usually the x. It's what you're inputting. Dependent is the y. So if I look here, f of x equals x squared plus 2. Find f of -3. So all that means is I literally substituted in -3 where x is. So 9 plus 2, that's 11. That's what the f of -3 would be, 11. So now here if I look, there's g of x. Figure out g of 2. Well, g of 2 is just going to be 3 times 2 minus 2 squared. So 6 minus 4, that would be 2. B, g of 3 times g of 1 means I have to do, figure out the g of 3, figure out the g of -1, and then multiply those. So that's going to be 3 times 3 minus 3 squared times 3 times -1 minus -1 squared. So this ends up being 0. 0 times -3 minus 1. Doesn't really matter. 0 times -4, it's still going to be 0. 0 is my answer. So last piece, 3x. Find g of 3x. Well, that means 3, but instead of x, I put 3x minus 3x squared. So this becomes 9x minus 9x squared. There's my simplified answer. So just to recap, function notation looks like this. And if I have a number there, all I do is substitute it in. X is my independent variable. Y is my dependent variable. So kind of another way to think about it, independent, this is the input. Dependent, that's going to be the output. What happens when I put that in for a function? So linear equations, linear functions, kind of what's the difference? Linear equation have no other operations than addition, subtraction, multiplication by a constant. Linear function, y equals mx plus b, that's what you're used to. You can also have standard form. So if I look at f of x, 3x, yes, that's going to be linear. Why? Because there's no x squared, there's no square root of x, it is just 3x, okay? There's one variable there. So if I have 7 over x, is that linear? Absolutely not. Why? Because I'm dividing by x. And take a second, throw that in your graphing calculator and kind of see what that looks like. It's a little weird. It's a little trippy. So take a look, because it ends up looking like this. And there's no way you're going to convince me that that's going to be a line. Last one here, x to the 4th minus 5. Is it linear? Absolutely not. Why? X to the 4th. X to the 4th is your dead giveaway that is not going to be linear. And if you graph it, it looks almost like an x squared, except it widens out a little bit more, like that. So that's what that looks like. So here, this is almost in standard form, but not quite. So what I want to do is subtract over the 12. Now it's in standard form. So when I do that, to figure out the x-intercept, anytime you see intercept, that means that the other thing is 0. So if I'm figuring out the x-intercept, that means y equals 0. So that means 3x minus 4 times 0 equals negative 12. So 3x equals negative 12, x equals negative 4. So x equals negative 4 right there. For the y-intercept, that means x equals 0. So that's 3 times 0 minus 4y equals negative 12. So minus 4y equals negative 12, y equals 3. So y equals 3 right here. So together, that's what that line looks like. Now I can flip it around and go to slope-intercept form. That takes too much time. Figuring it out from intercepts is just faster. So here it's already in slope-intercept form, but if I do it using the intercepts, you know, y equals 0. So that means 3x minus 9 equals 0. Okay, so 3x equals 9, x equals 3. So at x equals 3, there's my point. Y-intercept, I'm going to cheat and just say, you know what, I know it's a negative 9 because this is slope-intercept form. If I actually followed steps, let x be 0, it will take about 3 seconds to figure out that y is negative 9. So then draw my line. Boom, I'm done. All right, it's a lot of review. It should come back to you. Let me know if you got questions. Let me know what I can help you with. Thank you.